Let's do extrema and average rates of change. Okay, so first and foremost, we're going to talk about extrema. And when we say, right, when we use the word extreme, right, extrema, it does have the meaning of extreme, right? So either extremely high, extremely, so basically the very, very highest or the very, very lowest, right? So the extreme points on a graph. Okay, let's first talk about what it means for a function to be increasing and decreasing and constant. All right, first of all, when we read functions, right, a graph, when you look at a graph, we always read a graph from left to right, okay? So always read, right, and I put that in quotes, read graphs from left to right. Okay. If a function is increasing, right, that means as you go from left to right, the function values are getting higher and higher and higher, right? And if you see this one, if you're here, here's where your y value is. And then if you move to the right a little bit, your y value is higher. If you move to the right a little bit more, your y value is even higher and higher and higher and higher. That's what it means for a function to increase, right? You could it's visually very obvious that this is increasing, right? A decreasing function is the opposite. As you move from left to right on the x-axis, the values of the function are going to be decreasing. So when you're at x equals 0, here's your y value. If you move to the right, your y value is lower, then your y value is lower and lower and lower. So that's a decreasing function. Well, another way to say that is as you move over, there is a positive change in your y values, right? So the y values are changing and there is a positive change, okay? In x, a positive change in y. Here, a positive change in x results in a negative change in y. That means it's decreasing. So if there is no change in y, we say the function is constant. Okay? 0 change in f of x means the function is constant. So here, in this part of the graph, the function we say is constant. Okay. Now, right. So often, okay, so two things happen often. One, students follow the arrows. So in this last example, students will follow the arrows a lot of times. And because there is an arrow that way, students will say, oh, that's that's increasing. But no, remember to always go left to right, okay? All right, what we have to do when we see a function, often we have to determine where it's increasing and where it's decreasing. When I say where, I mean the x-axis. So consider the following graph. Determine the intervals on which the function is increasing, decreasing, or constant. Interval, here's the most important part. Interval is x values. We don't care about the y values. That's the x values. So here's what I say. Does that mean right, here's what we're going to do. So you look at this function, and we have to read it from left to right. And you see, if I start on the left, what is this function doing immediately as we start off? It's increasing, right? From left to right, it's increasing right until here. Okay, so not at 7, at -3. Okay, so it's always, so we are the least concerned with the y values. It's all about the x. So it's it's increasing here. Then what does it start to do? Decrease right until here. And then it starts to increase again right until here. And then it's constant. Right? So you wouldn't have to label like this every single time. What you would have to do is this. Okay, so where is it increasing? Where is it decreasing? And where is it constant? Right? So it's increasing from negative infinity all the way to negative 3.
Would it not be a closed?
Hang on. Okay, and then it's increasing again from 2 to 6. When we're doing these, always open intervals. Okay? Always open intervals. Okay, now it's decreasing from negative 3 to 2. And then it's constant from 6 to infinity. Okay, yes, Idan.
Why wouldn't
We see. All right. Okay, so let me zoom in here a little bit. So look at this. This is increasing, right? And then what happens? Does it ever stop increasing?
No.
No, it never stops increasing. All right. So we say this is increasing from negative infinity to infinity. What about the next one?
Does it not go constant for a little bit?
It does not go constant for a little bit, because if you look at the function, as you increase your x values, the y value will always increase. There is never two x values that are going to give you the same y value, so it's never constant. Okay, so what about the next one? First it's decreasing, then it's increasing, right? So we say it's decreasing from negative infinity to what? 2. And then it's increasing from 2 to positive infinity. Yeah.
How is there not a constant at A? Or how is there not a constant at A?
Here? Okay, so it looks like it's leveling off there, right? So let's see with, let's think about putting in different values of x, all right? So suppose you put in like x equals negative 0.2, then negative 0.1, then 0, then 0.1, then 0.2. What do you think will happen to your y values if you're putting them in here? So 2 times, right, if you put in 0.2 cubed, then if you put in 2 times negative 0.1 cubed, will your y values stay the same? Well, but 0.2 cubed and 0.1 cubed, would those be the same? No. No. Your y values are always going to be changing, right? That means it's not constant. There. Okay? That's why it's always going to be increasing. And also, if you look at this function itself, the bigger the x values, the bigger the y values are always going to be. All right? So if you have like 0, 1, 2, 3, your y values are always going to get bigger, 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 bigger. Okay. So here, where is it increasing? What do you guys think?
From negative infinity to 0.
Negative infinity to 0, and then it's constant from where to where?
0 to 3.
0 to 3, and then increasing from 3 to infinity. All right, so take a second and do part D for me, please. All right, so where is it increasing? To negative 1. And then 1 to infinity. And then does it decrease anywhere? Negative 1 to 1. Okay? All right. Now, okay, so before you turn to the next page, look at what's happening here. This is increasing, increasing, increasing until x equals negative 1. And then at negative 1, it starts to decrease, 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 right? There is a point here where it decides to turn around, right? So it was increasing, and then it decides to turn around. That point where it changes from increasing to decreasing, the function creates a maximum for itself. right? A maximum value. And then here, if you look at this, it's decreasing, 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 and then it decides to change to increasing. The point where it changes from increasing to decreasing, it creates a minimum value for itself. All right? Now, I chose my words very, very carefully there because this is an official definition of how you get a minimum or a maximum. What did I say needs to happen in order for you to get a maximum? Anne? Exactly. The function has to change from increasing to decreasing, and then vice versa for the minimum. All right? This is important. Yes.
So if it was like up and then straight and then up,
right,
and then down,
not the same.
Yeah.
Yeah, exactly. All right. So let's talk about extrema. Okay, extrema means max or min. All right. And again, it happens or it occurs when function changes between increasing and decreasing. This is the official definition, all right? And then you'll add to that in calculus. Okay. All right, so a relative maximum, I'll simplify this for you. A relative maximum is any time the function changes from increasing to decreasing. Okay? An absolute maximum is the absolute highest value of between all of the maxima. Okay? So, these here and here, relative maxima. Which one is the absolute maximum? The one on the left or the right?
The right.
The one on the right, this is the absolute maximum. So if I say, state all of the relative maxima, state the relative maxima, you give me everything. You don't leave out the absolute, you give me everything. If I say give the absolute maximum, you give me the highest one. Okay?
It's local.
So, relative maximum, so provide all. Okay? Now, so the book, the way the book labels this, it's sort of misleading. So don't go with this necessarily. If I want the relative maxima, give me everything. Okay. Minima is the same, right? You have relative minimum, and then you have absolute minimum. Okay? Again, here and here, this is the absolute minimum. So again, if I ask you for the relative minima, give me all of them. Another word for relative min or max is local min or max. Okay? Where should I write that? Local is the same as relative. Okay. Okay, now, important. If I say, provide the minimum or maximum value, what am I referring to? Value. What does the word value mean?
Would it be like any value in the graph?
So value, if I say minimum or maximum value, I want the y coordinate. Okay? Min or max value, that's the y coordinate.
So how would you write it? Would you write y equals
F of x.
Right. Either y equals, or we say like f of blah equals blah. Okay? All right, so let's do a couple of examples and I'll let you know what I want. Okay. Estimate and classify the local and absolute extrema on the graph of blah, blah, blah. Okay? So we're going to estimate and so on. Okay, so we clearly have an absolute max here. Okay, where is that absolute maximum?
Negative infinity and infinity.
No, where is the absolute maximum? At,
Zero.
okay, so absolute maximum at x equals 0. That's one way of saying it. This provides the least amount of information. A better way of saying it is absolute maximum at 0, 3. The best way to say it is absolute maximum at f of 0 equals 3. Okay, so it's like good, better, best. Okay? Yeah. This, okay, so if you say this, you always know you're giving all the information necessary. All right? This one just says it's at x equals 0, but you're only giving half the information, right? It's like telling somebody I live at, 3479. Okay. Oh, is there a street anywhere, right? Okay. So where are the minimums? Okay, so there is relative min. Okay, where are these relative min? It looks like it's -1 and -1. And 1 and -1. Okay, questions? Yes, Elliot.
Is it relative because there are two of them?
Correct. Yeah, I mean, okay.
You have to say what the relative maximum is.
Huh?
There is no relative maximum,
No, there was only one, and that's an absolute maximum.
and you wouldn't also classify it as both a relative maximum.
No, that's no. Okay, so here we go. Estimate and classify the extrema for the graph of each function. I don't think we need a calculator because I think these are pretty clear. So, what do you think? What's going on here?
There's only one.
Right, right. There is an absolute minimum at.
F of -3 equals -3.
Right. So this one I'm going to leave it in coordinate form just because. And then I'm going to specify. Okay, so I'm going to give you guys a little bit of more terminology. Okay, so we can use that coordinate point in order to describe this function in two ways. So the point is at -3 and -4. We say the location is at x equals -3. And then the minimum value is y equals -4. Okay? So there are many, many different ways of asking the same thing. You just should know which one, right, fits where. So like if you take like subject tests, this might come in, and next year, yes.
This is just like the different way, right?
Exactly. Different way of asking. So if I asked you for the locations of all the maxima or minima, you would give me the x values. If I wanted the y values, this is one way of doing it, or you could say f of -3 equals -4. But just know that value is for the y value, the y-axis. Right? And that makes sense. The minimum value that this graph ever reaches, the lowest that it ever goes is -4. Okay? All right. So here, what's going on here? What is this? We have it looks like we have an absolute max here. Right?
I just think there was a relative max.
Yeah, because it goes higher.
There's two,
Where does it go higher?
On the right.
isn't there at the half relative?
Huh?
At the half?
At the half here?
Yeah.
But does that go higher? In value, does it go to a greater altitude? Yes, that's a relative maximum. So we can just say that that's a maximum, right? You can say a relative, or it's not necessary. Absolute max is a good one to, you definitely need to say that. And then what about our min? I have a minimum here, just an average old minimum, and then I have my absolute minimum here. Why doesn't this point count as a absolute max? Yeah. It never stops. It's going up. What needs to happen for it to be a maximum? It needs to change from increasing to decreasing. Okay? All right. So we have an absolute max at -1 and 2. We have a relative max where we can eyeball. Or you know what? Let's not eyeball. I'll do this with we'll do it with the calculator right now. There is a relative min at 0, 0. And then there is an absolute minimum here, but I want to use the calculator for that one as well. So let's put this in the calculator quickly. All right, let me stop this for a minute. Okay, so that's the way you're gonna round, right, for absolute minimum or maximum and relative minimum or maximum. All right, so for today, I will stop here. You have your quiz tomorrow. I suggest, start on some of these since it's fresh in your mind. And then tomorrow, I absolutely need to finish that last bit of the section, okay?